Good morning, students. It's August 14th of 2019. I just wanted to round out what's been a theme now for a while because of the grand opening of an art gallery downtown projected for, say, October. And that's got me in didactic mode vis-a-vis lattices, and in particular the CCP. Now, I use CCP as one of my search terms with rhombic dodecahedron, and you would think, given the intimacy of those two concepts, that we might see more ball packing. I see two so far, and they're both by me, right? So this is something I did with POV ray. Let's see what it shows. It's not very big in this, but those are rhombic dodecahedra with, by the color, I could say ping pong balls inside. And the ping pong balls, they're all intertangent, and they're intertangent through the face centers, the diamond faces of the rhombic dodecahedron. That's also by me. So there aren't a lot of these. And then there's an explicatory one, which is by David Koski. This is a really interesting one. Here we see the internal cube of the rhombic dodecahedron. You have to kind of ignore some of the lines as you're looking at this. And just look at the short diagonals of the yellow diamonds. So the yellow diamonds here are the 12 faces of the rhombic dodecahedron. These are where the spheres come to the centers and touch each other. Spheres in the 12 around one packing. And what's different, okay, none of this is like a new discovery, right? Maybe you think, well, what do you think, Bucky discovered this or something? And no. Right? Kepler was really into this. Kepler, and we can go back. We can look. I'm interested in the history of this as much as you are, and not the authority. So what we've been doing in recent videos is I've been holding actual spheres of different substances, spherical in the sense that, you know, they have bumps and holes in them, and that could have been full of coffee. That would have been a disaster. Fortunately, my coffee is over here. Anyway, I won't get to C60 right now. You've seen it, last two videos if you haven't, made out of plastic. The theme being this particular lattice. And what's different about the fuller curriculum is this famous rhombic dodecahedron. We're consistent in including it in a small set of polyhedra that we call the concentric hierarchy. That's just shapes in relation to each other. And it's kind of a home base. It's our suitcase of tightest packed geometric concepts. And it begins with the tetrahedron, goes through a cube of volume 3 and rhombic dodecahedron of volume 6. And then there's a constant. So if you want to stick with X, Y, Z and go back and forth, that's all there. That's the part that Bucky added. I call that whole number volumes. And when I talk about maybe OMSI being interested in an exhibit on that, I'm thinking of something like pouring a substance, just like I do in the classroom, like 2 cubes pour to fill a rhombic dodecahedron. But it might be plexiglass, it might be colored liquid, it could be a fountain, it could just be a steady flow of water that recirculates through, but the volumes are demonstrated. Maybe something dumps into something else, or a valve opens, water falls into the next thing. 3 tetrahedrons or 4 tetrahedrons would fill that octahedron. 3 would fill the cube. There's lots of ways you could wire up a wall display with relative volumes and water falling between, something like that, colored liquid. So I was thinking of an exhibit like that, clearly outside the scope of the pop-up gallery downtown. We're not going to be doing things like that there, okay? So whole number volumes, sphere packing, CCP, rhombic dodecahedron. I think you got that now, and I think you're glad you did, and we'll talk to you soon.